Hi all, welcome to the session on computer vision. In this video, you will learn what is computer vision, how computer vision works, some of the applications of computer vision, and finally, some best Python libraries that can be used for this one. Let's start. Vision means the ability to see. So, computer vision means you are giving the computer an ability to see and understand images and videos. You can see a picture, right? In that picture, you can see a building, some trees, a statue, some cars, etc. So by computer vision, you should able to make computers more intelligent to infer some of the valuable information from this image. For example, like what kind of scene is this? Where are the cars? How far is the building? So this is a normal view of an image for a human. But when a computer sees this image, it will interpret that image as a group of numerical values. So we can define computer vision as a field of artificial intelligence that trains computers to interpret and understand the visual world. Machines can accurately identify and locate objects, then react to what they see using digital images from cameras and videos. So how the machines are accurately identifying the objects? That's a question. Digital images are actually a collection of pixels. In other words, you can say pixels are the basic building blocks of any images. The pixel value at a particular location will contain the information at that position. The variances in the pixels helps to infer the features from the image. So for a grayscale image, the pixel values will range from 0 to 255, and for a colored image, it will be a combination of RGB, R for red, G for green, and B for blue. So for a colored image, it will be a value representing these three main components. And with the variances or with the change in these pixel values, we can capture the features from the images. Let's see some of the most exciting examples of computer vision in practice today. The first one is autonomous vehicles. Computer vision is necessary to enable self-driving cars. Manufacturers such as Tesla, BMW, Volvo, and Audi use multiple cameras, lidar, radar, and ultrasonic sensors to acquire images from the environment so that their self-driving cars can detect objects, lane markings, signs, and traffic signals to drive safely. The next application is Google Translate app. All you need to do to read signs in a foreign language is to point your phone's camera at the words and let the Google Translate app tell you what it means in your preferred language. By using optical character recognition to see the image and augmented reality to overlay an accurate translation, this is a convenient tool that uses computer vision. The next application is facial recognition. In most of the countries, facial recognition technology is used for police work, payment portals, and for security checkpoints. For example, the security checkpoints at the airport. The next application is healthcare. Since 90% of all medical data is image-based, there is a vast use for computer vision in medicine. It can be used to analyze X-rays, mammography, and other scans to monitor patients to identify problems earlier and assist with surgery. The next application is real-time sports tracking. Ball and puck tracking on televised sports has been common for a while now. Computer vision helps to have a strategy analysis, player performance and ratings, as well as to track the brand sponsorship visibility in sports broadcast. The next application is in agriculture field. It is used to analyze grain quality, to identify weeds so that herbicides can be sprayed directly on them instead of on the crops. The last application is in the manufacturing field. Computer vision helps manufacturers run manufacturing plant more safely, intelligently and effectively in a variety of ways. Packaging and product quality are monitored and defective products are also reduced with computer vision. So that's it about the applications of computer vision. Let's see some of the best Python libraries for computer vision. The first one is scikit-image. That's a collection of algorithms for image processing in Python. Next one is SimpleCV. That's an open source computer vision framework that gives access to several high-powered computer vision libraries such as OpenCV. The next one is Vigra NumPy. That's a Python binding for Vigra C++ computer vision library. Next one is OpenFace. That's a free and open source face recognition with deep neural networks. The next one is face recognition. That's a library that recognizes and manipulates faces from Python or from the command line. The next one is Dockerface. It's easy to install and it uses deep learning faster RCNN face detection for images and video in a Docker container. The next one is Dectron. It's also written in Python and powered by the Caffe2 deep learning framework. The next one is Argumentations. It supports classification, segmentation and detection out of the box and was used to win a number of deep learning competitions at Kaggle. The next one is PyTesseract. That's an optical character recognition tool for Python. The next one is IMUtils. That is a library containing convenience functions to make basic image processing operations such as translation, rotation, resizing and displaying. And the last one is PyTorch CV. That's a framework for deep learning in computer vision. We have seen what is computer vision, how computer vision works, the various applications and finally the Python libraries for computer vision. Thanks for watching. Stay tuned.